Alright guys, so this video is just going to be called factor form. Um, I want you guys to go ahead and we're going to start with A. I always like to start with A. Now, if you get an equation that looks like this, and this is the last equation that you're going to be seeing. Now, you notice that we have parentheses and we have R1 and then we have R2. I'm going to go over what those means right now. But I just want you to look at A. So if you get this type of problem, you have A. Again, if A is equal to a positive, then you're going to have concave up, just like on the last two. If A is equal to a negative, then you're going to have a concave down. That's literally all it takes. Okay, that's going to be the very first thing that you need to do. Now, the second thing that I want you guys to focus on is how your problem actually looks like. So we're going to have a problem over here on the side, and I'm going to write this one down. It's going to be 3. We're going to be using some of the stuff that we used before, plus 1. And then we have x plus 2, plus 3. As you can see, r's are basically going to be the numbers that you had before, okay? R's are going to be the two different numbers inside of, it's basically the 1 and the 3. And those are factors. You know, this whole thing is factors. That's why it's called factor form. And it's showing you. In factor form, there's really awesome thing about factor form, and I want to cover something real quick. Whenever you get a factor form problem, first thing I want you guys to actually go ahead, you know, whenever we got factor, whenever we got the vector, the vertex form, the easiest thing to find was the vertex. Whenever you have something in factor form, the easiest thing to find is going to be your factors or your x-intercepts. So we're going to be looking for the roots, also known as my x-intercepts. That's the first thing I want you guys to go ahead and find whenever you get a problem like this. And it's going to be relatively easy. All you have to get is get whatever's in parentheses, and you're going to have to equal it to 0. So x is equal to, or no. So x plus 1 is equal to 0. X plus 3 is equal to 0. So all we have to do is minus 3 minus 1. That's minus 3 over here, minus 1. So those two cancel out, so I have x is equal to negative 3. And over here we're going to have x is equal to negative 1. I already find my two different factors, or my roots. My x-intercepts are going to be negative 1 and negative 3. And that's it. That's the first thing. Now the second thing that we need to find, we already figure out if my equation is going to be concave up and concave down, right? This 3 is positive, so it's going to be concave up. So I already know two things. Now I just need to find the last two, which is my vertex. How am I going to find the vertex while looking at this guy right here? So we're going to see right here, it looks crazy, right? It's like, how am I going to find my vertex? By looking at all this craziness. Right, it seems like we have a lot of stuff, like, where do we even start? I want you guys to go ahead and look at your two answers that we got over here. Negative 1 and negative 3. So if I were to graph it, I'm actually going to go ahead and graph it just to visualize it better. So if I were to graph this one, I'm just going to do a random parabola, right? I have this, I have this, I have my x, and I have my y, right? I don't know exactly. Okay, that's horrible. That's actually not how it's going to look. So I have this. Yes, that's more like it's that's a little more like it's gonna look. So now this is negative 3, and this is negative 1. Okay, so now what they're trying to figure out is what is in between my negative 3 and my negative 1. So guess what? Right here, the middle of my actual thing. So the distance, the middle distance, or the if I cap my distance between negative 1 and negative 3 is going to be negative 2. Because that's the number that's literally in between negative 3 and negative 2. So that's actually going to be my first, my x for my vertex. Okay? That's how we find the first one. Alright, I'm going to repeat it again. I'm going to erase it. So I'm going to go ahead and erase it a little bit again. So I have negative 3, and I have negative 1. If I want to see the distance in between both of them, I need to cut them equally, right? So if I cut my distance in the middle, the number that's in the middle is going to be negative 2. Alright? And that's literally where my axis of symmetry is going to be, but we'll talk about that later right now. So that's negative 2, right? Now, all I have to do to find the y value, I need to actually just go up and plug in negative 2 for all the x's. So I'm actually going to go ahead and do that. So I'm going to have y equals 3, parentheses, and I'm going to be plugging x. So it's going to be negative 2 plus 1. Going to be negative 2 plus 3. Now, negative 2 plus 1 is going to be negative 1. Parentheses. Negative 2 plus 3 is going to be 1. And then I'm going to have a 3 over here. And I'm going to have y. Now, negative 1 times 1 is negative 1. Parentheses. 3. Now I have y is equal to 3 times negative 1. And now it's y is equal to negative 3. Okay, that's going to be my second value for you. So if I were to do this, I would go negative 3. So this would be around here, right? That's negative 3. Actually, that worked kind of well. Kind of looks pretty good. So that's how actually my graph is going to look. I already graphed it just by knowing everything. So that's where my vertex is, right? Now, how to find my axis of symmetry? And just like the previous videos, is the same thing. You're going to start with x, and it's literally your x value of your vertex. So it's going to be x is equal to negative 2. And that's it. I'm done. I have my vertex. I have my graph already graphed. I have my 2 points. I have everything that they were asking me to do. Alright, pretty self-explanatory, so I hope you guys like that one. This one's not the shortest. It took a little longer just to explain it, but that's